In this episode of Automation Tech Tips, I sit down with Sandro Quintero of Festo to learn how you can quickly import a complete CPX API system right into Studio 5000. Sandro, thank you for coming on the show and offering to show our audience everything we need to know to use the CPX API product line.
Yeah, thank you, Shawn, for the invitation. I'm really happy to be here. So as you can see here today, Shawn, I have some hardware, and you see this is live right now. I have some CPX API modules that I'm going to be explaining here in just a second. And then I also have a Rockwell PLC that we're going to be using to control these modules over Ethernet IP. But before we go into any of the hardware details, we got to start with just a quick introduction on a little bit of the theory of what this is, right? How this works. So let me jump over here. And now you can see these CPX API modules, right? So what is this about? And let's start with the basics, right, Shawn? This is the different architecture types. So as you know, in machine design, there are different architecture types that you would use depending on the type of machine that you're doing, the type of industry, of course. And here I wanted to show you the basic ones. So as you know, the centralized topology is probably the most common one, right?
Yep.
This is when you have, your PLC or your CPU inside of a control panel, and then that CPU has, a bunch of I/O cards, right? Then basically what you do is you come back to that main control panel with all of your sensors, cables from the sensors, and then you send all of your cables out to, valves and so on. So that's why it's called centralized. Then we have the modular, which is basically now you kind of like start to decentralize. Now you have maybe a module somewhere else in the machine where now you can scatter your I/O throughout the machine. And it looks like this. So you have your CPU, and that CPU communicates to a node that's somewhere else, right? And then the topic for today is actually decentralized, right? And in this case, what we have is we have our CPU here with some I/O, but that now we have a node somewhere in the machine, and that node is able to communicate to additional I/O modules that can be really close to the process in the machine. And of course, as you can imagine, these I/O modules can be gathering data from the sensors and sending data to the actuators and so on. The last one is just the hybrid, which is a combination of the previous ones. I'm pretty sure you have seen this before, right, Shawn? I mean, this is pretty standard in the industry.
Yeah, I think and most of our viewers probably one and two, the centralized and modular, probably what they're most used to. But I can see in the future decentralized with new technologies coming and hybrid being more and more found in newer systems.
Exactly, exactly. Now, a lot of your viewers might be like, okay, when does it make sense to use which one, right? And if you can imagine, I'm just gonna, there's a lot of text here, but I'm just gonna mention a couple of things. If you can imagine centralized, it can be cumbersome if you have many I/O, right? Because that would mean that you have to run long distances of cables just to go back to a central control panel. And nowadays you have, like, for example, on the packaging industry, you have these huge lines, right? Very lengthy lines, conveying lines, for example, which would be, I mean, realistically, it would be very difficult or cumbersome to bring all of that data back or those cables back to a single point. So in those cases, it makes a lot of sense to use a decentralized, as you can see, decentralized approach, because now you have I/O scattered throughout long distances. It also helps with complex architectures. I've also seen a lot of users prefer the decentralized approach to have the I/O closer to the process. Why? Because imagine if you have the valve, for example, a pneumatic valve, really close to the pneumatic actuator, that means that the reaction time for that pneumatic actuator is really quick, right? So there are several things here that we have. Is there any point from this list that catches your eye or something, Shawn, at this point?
Well, haven't been out in the field for 30 years. There definitely those very long, large systems are
Mm,
where that modular type of, distributed I/O is very helpful. But even when we start looking at skid-based systems, systems that are more compact, where they could have 100 or 200 I/O, but it's on a
mhm.
compact machine, we're seeing people get away from the centralized and going to on machine, just because the cost of running everything back versus a field bus of some type.
Right.
It's still landing everything on a terminal block and then wiring in those quick disconnect cables along with, on machine type devices can save maybe not the pure hardware bill of materials, but the overall construction and wiring. It saves a ton on the on the cost of putting the system together. So those were kind of my thoughts as you were going through that we do see these everywhere because of different needs.
Right. And you were talking about mainly the point number three, or the third point there on those lists. And I've seen this all around, like companies preferring to use M12 and M8 connections because they're super quick. You just get the cable pre-assembled and everything, and you can just connect the sensor. While in the past, when you were, for example, wiring a multi-pin valve manifold with a sub D25, as you mentioned, you will have to terminate every single wire, and you multiply that by how many valve manifolds you have, it starts adding up, right? So now I wanted to show you here a let me just get rid of my face so you can see the whole slide there. What I wanted to show you here is how this looks like in an actual machine, or like the topology of a machine. As you know, usually in a machine you have several different devices, right? So I'm just going to go through some here. So you would have your PLC, right? Your PLC would be somewhere here, for example, in this control panel. And then you have a bunch of different devices scattered throughout all of the machines. So for example, in this case, I have some servo drives here in this other control panel that are probably driving this C axis here for some packaging process. Then I have some other servo drives here to control something that's going inside of this enclosure. If we keep going, we also have, for example, some remote I/O cabinet here for something else in that process. We can have more I/O, and then here we get into the point of decentralized remote I/O, and that's what I'm going to explain in just a second. But let me just keep going. So the decentralized remote I/O, it's basically here. I'll get to that in just a second. But I just want to explain, all of the different devices that are usually in these machines. So you have I/O modules, valve manifolds, end-to-end actuators. This could be pneumatic or electric, vision systems, HMIs, and so on, right? If you noticed, I'm going to go back. If you noticed, I have this, right? So everything in this example, everything is being driven over Ethercat. So all of these devices are interconnected over Ethercat. Now, if we keep going, we see that now I have the same architecture, but being driven over Ethernet IP. If I keep going further, now it's Profinet, and then it's going to be Modbus. Why am I showing different field buses? Is because we are experiencing this, right? Machine builders usually are tasked with building maybe the same machine over and over again, but depending on who the end user is, the end user might have a different standard for field bus communication. So let me just go over here. So now we can jump into the hardware and explain what I have. So this is the hardware. This is how it looks like. This is how it's going to look like when I show it to you on the camera. So what we have on the hardware side is the following. So I have, as I mentioned at the very beginning, I have in this case a Rockwell PLC that is communicating over Ethernet IP to a module, right? So let me show you that here. It's actually this green cable that I have here. So this green cable is connected to the Rockwell PLC, that's Ethernet IP, and it's connected right here. Perfect. We have that now. So now from this module, what I do is I branch out to several other different modules, which these modules can be I/O modules for, digital I/O modules, analog input modules, and even valve manifolds like I'm showing here, and also IOLink. So this is an IOLink master module, okay? Now, you probably noticed, Shawn, at this point that there are two lines coming out of this main module. There's a
Yeah.
blue line and there's a black line, right? And I'm pretty sure that you're like, okay, I see a black line and I see 24 BDC down there, so that's probably power. And you would be right. We're fine until there, right?
Yep.
Okay, perfect. So yes, this is 24 volts that I'm supplying with a power supply. And basically that is feeding the whole system, okay? I'm gonna get back to that in just a second. What you can do with power supply is you can daisy chain all of these modules and share power, right? between modules. Now, the blue line that's being depicted here, this is a communication protocol that we use that it's called AP bus, and AP stands for Automation Platform. This is a bus that we use to communicate every module between each other right below Ethernet IP, okay? You can think about it as, well, I wouldn't say IOLink because IOLink it's somewhat limited in terms of speed and some other things, but it's just a communication protocol, okay? Any questions up to there, Shawn?
No, so it's almost like a sub field bus. So we have our main field bus, our trunk, our Ethernet IP or EtherCAT or Profinet, Modbus TCP, but this is the distributed one level below that. So
Correct.
we have our can have all these AP modules on this, let's say, a conveyor or whatnot.
Correct. Usually the question might be like, okay, but I don't know anything about the AP bus as a user, right? And you don't
Mhm.
have to, because there's nothing for you to set up, or,
Oh,
usually when you're
okay.
dealing with Ethernet AP, you know that you have to register the EDS file for every, device and so on. The nice thing about the beauty about AP is that all of that is happening on the back end, okay? It's basically like, modules from other brands out there, for example, a PLC rack, usually there's a backplane that's running
Mhm.
on the PLC, and there's a communication bus running on the backplane that you
Mhm.
never ever deal with. You usually set up Ethernet IP, and the rest is set up for you. In this case, it's the same approach, with the only difference here that now you can see that cable for that communication, let's say, backplane. Okay.
Okay. Yeah.
Yeah.
Now, is
So
there any, well, you probably show this, but I'm thinking, is there like a dip switch on here? Say this is number one, this is number two, this is
ah,
number three. So I'm probably getting ahead of myself.
no, 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 that's perfectly fine. Those are really the common questions. There are no deal switches for you to specify which module is which. And that's what I'm going to show you. These modules, what they do is, this is how you set this up, okay? You basically connect all of the modules. So I have the main module, and then actually let me step over there so I can show you. I'm going
Okay.
to step over here. What I did here is I start with this main module and I put
Mhm.
power to it. So this is going to my power supply. And then from here, as we mentioned, I start doing a daisy chain connection to all of my different modules. So I go in here, come out, go in the valve manifold, come out, go to the next one, go out, and so on, right?
Mhm.
Same thing happens with the communication with the AP bus. So I go out, come in,
Oh,
go out, come in, and so on. Now, you mentioned deal switches, and that's a really good question, because in the past, this was the way of setting up these kind of devices. But now what happens here, basically what I do is, now that I have everything connected, all of the power and communication cables, I power up this module, and this is the beauty. This module pings everyone that's connected to it and says, who are you? Who are you? Who are you? And so on. And then he says, I'm a valve manifold. In this case, this is a 4 digital input, 4 digital output module with M12 connections. I'm an 8 digital input module, and so on. So this guy in Power Up, it recognizes everyone that's connected to it. So you don't have to set anything on who's who.
Mhm.
So how does that look like in the programming environment? Let's see. The way that looks like is like this. Let me just jump over here. So here's one of my favorite features about this. The way for you to set this up is you basically go into any browser. Like in this case, I'm showing you Google Chrome.
Okay.
And what I did here is I just typed in the IP address of the main module, this one. I can do that again for you. So what I'm going to do, oops, let me just open that again, Chrome.
Sure.
So Google Chrome, and I'm just going to type in the IP address of that. So 192.168.4.120 in this case, and that's connecting at this moment. I don't have internet connection in this VM, but that's connecting in this moment to this module, okay?
Mhm.
And this module automatically recognized all of the other modules that are connected below it. So you can see here, it even recognizes everyone by serial number and also a unique identifier. It tells me the firmware version of each module and so on, right? So that's another thing. You don't need any special software or anything to set this up. Um, what can I do in this web server or this web browser, right? What I can do is I can look into parameters for each module. What kind of parameters? So for example, if I click on this valve manifold, it tells me, okay, it's this. So now if I click on that, I open the, I expand the options for that module. And now here I can see what kind of parameters can I set up for this. And there's just two for a valve manifold. I can monitor the load supply. So in case that there's something going on, I can, monitor if there's an error with power supply. And I could also, this is an interesting one, I could also configure the behavior in fail state for the valves. That means what happens if suddenly I lose communication to the, to the PLC? What do I want to do if coil 1 was on? Do I want to leave it on, like hold last state, or do I want to reset it? Okay.
Yeah, that's very important. Yep.
Right, so those kind of things. So each module has different parameters. I'm not going to go over every single one, but the other thing that I wanted to show you here is we could also see the cable lengths between modules. So for example, it's telling me that this module has a cable length of 0.5 meters connected to it. So now each module will tell me the cable lengths. Why am I talking about cable lengths at this point? Well, let me just for a second go back to this slides that I was showing you earlier to show you the following. These are the different modules that are available. So we have EtherCAT, Ethernet IP, Modbus, Profinet, and Profibus. As you can see, we're covering the main field buses out there nowadays. Then we have 8 digital inputs, 4 digital inputs, a combination of 4 the I, 4 the O, then 4 analog input module, which includes RTD signals, so for temperature, temperature sensors, and then an IOLink master. The reason why I was talking about cable lengths just a second ago is because we can support up to 50 meters between modules. What does this mean? Okay, let me go back right here. This means that between this module and this module, there could be 50 meters. Between this module and this module, there could be 50 meters and so on. So imagine these modules for one of these lines that we were talking about, like a conveying line. You have these long runs, right? So now you can really deploy modules where you need them, right? And everything can be controlled by a single IP address in this case, right?
Yeah.
Okay, so 50 meters between modules, and the other thing is below one of these modules, you can have up to 80 modules. So in this case, they have what, 1, 2, 3, 4, 5, 6. You can have up to 80 under one IP address, okay? Theoretically, you can do 500, but I can tell you so far, we haven't had an application that requires so many modules. Okay, the other thing that I haven't mentioned is the direct integration with valve manifolds, but I'm going to show you that in the software side. So let's jump into the software side again. And before I continue, Shawn, tell me if I've been talking for so long already, or if you have any questions so far.
No, good. Very good. Keep going.
Okay, perfect. So here's my favorite feature in terms of how do I set this up in Rockwell or in Studio 5000, right? I have a PLC. How do I set this up? Okay, so what I did, just for the sake of time, I created a project here, and this is kind of like an empty project. I just configured my PLC. I have an ControlLogix L18, and I just have the IP address set for that. Okay, we were good there. Now, how do I specify how many modules do I have and how do I map them in my IO, right, or my tags? Here's the way that you do that. You go into here in this Ethernet IP menu, click on Rockwell L5X project. Then once you're in here, what you're going to do is you can set up a name. Let's say this is for machine, or let's say station 34, for example, right? Then here, I'm just going to leave the defaults. I'm not going to get into specifics today. Just going to click submit. And then I'm just going to download this. And I already have a folder here that's called Insights in Automation. So I'm going to save that. And that's an L5X file. Okay. So now what I'm going to do is I have another Studio 5000 instance open here. I'm just going to open that file. So file, open. Then I'm going to go into Insights in Automation, Station 34, open. And then it's going to ask me, okay, you want to open this. In which revision of PLC? I have 31 running on my PLC right now. So I'm just going to hit import. And now on the back end, what's going on, and you're going to see this beauty. The whole configuration, including mapping, which module is which, IP address, it's already pre-configured for me and brought in into Studio 5000. So here's how that looks like. You see station 34.
Yep.
And if I double click on that, this already has the IP address that is set. If I go back here, you remember this was the
Yep.
IP address of that CPX-AP-I module. The IP address is set, and look at this beauty. All of the assembly instances are already filled out for me, and the sizes. This is usually a point where I've seen so many users, scratching their heads and going to their
Exactly.
Excel spreadsheets and trying to figure out which size is which, or which one they should put in here. All of this is already pre-configured for you. Now, if I go into my main program, you're going to see that I have a main routine already created for me. And basically, this main routine is importing my inputs, my outputs, and also the status, because each module also has some diagnostics. Okay, so let's leave it at that. And then if I go to my controller tags, look at this beauty. I have some UDTs. Actually, let me open the assets. I have some UDTs here that were defined for me, inputs, outputs, and so on, status, that now those UDTs are here. And if I expand these inputs, I can see module 3. Let me make this column smaller. It says module 3, and I can see which module that is. It says here that that's a CPX-AP-I with 4 digital inputs and 4 digital outputs and an M12 connection. So you see, now I expand this, and now I can see that I have 4 inputs in that module that I can access through here, right? So all of these, the descriptions for the tags and the UDTs are automatically created for you. Now, at this point as a user, I'm like, okay, what now? I have, let's say that this is my project, and this is an empty project, right? I don't have anything here. What I'm gonna do, this is the project for my machine. What I'm gonna do is I'm just gonna grab this module that was created on the L5X export, and I'm gonna bring it into my project. So I'm just gonna do paste. So there it is. I can open it on my project. There it is. Now I'm going to grab these 3 rungs, and this is an important step. You have to export them. So I'm gonna put them in there into Insights in Automation, export, and go back to my program. I'm gonna delete this empty rung, and then I'm gonna do import rungs, and then this file rung 0 to 2. Okay, open. It's important that you do the export and import process, because during that export and import, the UDTs are also grabbed into that package, into that L5X. If you don't do this, then the UDTs are not transferred. Okay, so there we go. Now I have this. Perfect. So we are at a good step here where I could, go online. So that's what I'm gonna do. I'm gonna download this into my PLC. Let's just give it a second. There we go. Download. While that is downloading, let me jump over here so I can show you this. So now you see that I have 2 connections. This is the IOLink master in this case. And I have 2 IOLink devices connected to it. I have an electric actuator that's driven via IOLink, and I also have a stack light, okay? So these are the 2 IOLink devices. On this other module, I also have something connected to it, and it's nothing more than just a button that I use to, check the inputs, okay?
Sure.
So you see that these 2 lights are off right now. That means that those IOLink ports are not enabled. So let me do the following. I'm gonna go back to Studio, and I'm gonna set this to remote run. As soon as I go to remote run, actually, let me see. I can go into the controller tags here, and I can switch on those IOLink ports. So if I go here, look into the configuration data, you can see all of this is the configuration data for all of the modules. There are a couple of ways of doing this. Yeah, with descriptions, exactly. There's a couple of ways of enabling the modules. I'm just doing it here the hard way, because I actually forgot to do it earlier when we were doing this, but this is the one that I'm going to set to 2. And then I'm going to set this to This is the second port. Just give me a second. Port 0, and then port 1. Okay, set this to 2. And now I'm just going to restart that module. So upon restart, now the IOLink ports are going to be enabled. So I'm going to inhibit and then do OK. And now if I show you my camera, now you see that these two LEDs are on, because basically what I did is I switched on the IOLink ports. Okay.
Now, could you have done that in a configuration like where we were looking in the Festo software? Could we have done that in there? Okay.
Yes, and that's exactly what I forgot to do. That's usually how I do it. So if you go into here, so basically what I did here is I went back to our web server and I opened the IOLink module. Then I scroll down and look for port mode. Here under port mode, you see that it says IOL or IOLink auto start. This is what I forgot to do, right? If you do this, like when you do this at the very beginning and then you export the L5X file, this configuration is going to go along with your L5X file. So you don't have to do it the way that I did it on the tags, right?
And this is all built into the module. I don't even need extra software. This is just the web interface of that module itself. That's awesome.
Exactly. So now let me, where was I? Oh yeah, I was in Rockwell. So let's test a couple of things. What I'm gonna do is let's close this out, this configuration data, and let's go and have a look at the inputs. So this is the UDTs, and I know that my button, the one that I showed you earlier, is connected to this module, this A digital input M12. So I'm going to expand this. And what I'm going to do here is I'm going to do the following. I'm going to press this button here. So I'm gonna start pressing it a couple of times. And actually, you see the LED back here, right? So I want you to see now that if we go back, now I'm getting the data here, right?
Perfect.
So it's telling me, okay, perfect. I'm getting the inputs there. So now let's test a couple of outputs. How do we test outputs? Well, luckily here, what do I have to test for outputs? Well, I have this valve manifold right here, right? So let's switch on a couple of coils. If I go here, and I'm in inputs right now, so I'm gonna go to outputs, and let's see. This BMPAL, this is the description for the valve manifold. So I can expand this, and you see, now look at this beauty. All of the coils are already labeled for me. So I could say coil 0, switch that on. And let me go to, oops, not there. Let me jump and show you that. So you see the coil 1 is on. Now I'm going to flip over here. Actually, let me put this to the side so I can be, jumping around. Okay, so now I'm gonna switch on actually all of the coils. So 1, 1, 1, 1. And I want you to see now that all of the coils are on, right? So now I'm testing outputs. And I guess as the last thing, the very last thing that I can show you here for testing purposes is what if we control that IOLink device that we had down there? So if we jump over here, let me see. We have this for IOL, which is the IOLink master. So I'm going to expand that. And I know that this actuator that I have here, I'm going to show it to you in just a second, is connected to the first port. So I'm going to expand that. And I know that in this case, this byte is the one that I can use to control this. So I'm going to set this to 2. And I'm going to be switching it from 1 and 2. Okay. I'm going to be doing that on my side screen, but I want to show you here. I'm just going to set it to 2 now. You see the actuator moving?
Yep.
1, 2, 1, 2.
Perfect.
Pretty easy to control. And again, this is an electric actuator. Maybe later on we can do a session on these ones because these have been very successful because they're really easy to use over IOLink. And then finally, Shawn, what I can show you, if I jump over here, what about that stack light that we had? If I close port 0 and I open port 1, let's set that stack light to yellow color. So I know these numbers already because I've been playing around. Minus 60, 11, and then 11, and then 1. And now I'm going to show you that that stack light is flashing yellow, right?
Nice.
How do you know these values? Well, you can just look at the data sheet for the stack light. If I wanted to set that stack light to, let's say, a green color, I would just change those values that I said earlier, 17, 17, and 1. And now we have a solid green stack light. And how did I do that? Just by switching these 3 bytes over here, 17, 17, and 1. And that's about it. As you can see, we are trying to make this short and sweet, but there's a lot of things that you can do with these kind of modules, and you have that beauty of being able to integrate IOLink devices to it. So now you can control, devices from any vendor that offers IOLink. Nowadays, there's a bunch of those out there. But what do you think, Shawn? Did you like those features on the implementation on Studio?
Well, I got to say, I think that first of all, for many people, they've just been using distributed I/O. This gives them another option to even, expand onto distributed I/O. So they have one drop, and now they have this whole subnet, or sub network that can go down the side of a machine. So I think that's exciting. But the fact that built into that device, you have the software not only to configure all these modules, but also to export your configuration to an L5X so you can import it into Logix. And I mean, what you're getting what you would normally have to do manually. You're getting the item added to the IO tree as the right address and the right instances and assemblies and all that. You're also getting the code needed to read and write things in,
Mm-hmm.
right? Because you have to do a read, you have to do a write. But finally, you're also getting fully documented you're getting UDTs, but those UDTs are fully documented based on your configuration. And
Correct.
so it really does in that one export, you're getting what would typically take an hour or two to kind of put together, very labor intensive, trying to document everything and whatnot. Now, the one question I do have though,
Mm-hmm.
and this is where I could see the people I work with asking,
Mm-hmm.
what happens if somebody wants to put a new module in between two
Uh,
existing ones? Right?
right.
That's where they're going to be like, well, I'm throwing a monkey wrench into the works here. So
No. Yeah.
what would happen if I did that? If I put a new module in between, let's say 3 and 4?
Yeah, it is possible to do that. We have a procedure. I can show it to you. It might take a little while because I need to pull out the document, but this is already documented. We have some application notes that
Okay.
show you how to do this in Rockwell, and I can tell you just in a nutshell what you will have to do.
Sure, sure.
Basically, what you do is when you put the module in between. This is a very common thing because a lot of the times you're like, oh, we forgot, some IO in this portion of the
Exactly.
machine. What you do is you go into the assets and you just modify this. I think it was one of these UDTs, either the
Okay.
inputs or outputs. You modify one of those UDTs, and basically what you do is you offset one of those modules. The reason why we do this is because we don't want you, like, if you already have all of your program, we don't want you to offset your mapping, right? Because
No,
if you don't
exactly.
make this modification, then all of your modules are going to be offset by a byte or something, and we don't want that because a lot of times, you have already 40 modules or something, and you don't you don't want 40 modules to be
Exactly.
offset. So basically, you go in here, you create an internal offset on the program, and that would be it. Then you don't have the problem with the mapping, and it's really simple to do this.
So
This
you
is
guys have
documented.
that,
Yeah.
you guys have it documented, you know what's going to happen. Like in a
Yeah.
chassis, you just put a slot filler in. And you don't
Ex-
use that slot. If that's for option B, you just leave that slot open. So you guys already have that all figured out and documented. That's good. That's good.
exactly. Yeah.
No, I'm excited to hear what the audience has to say, what they think about this. I thought this was an excellent. This is the first time I'm seeing this, and I usually, whenever we do one of these shows, I like to see it live when just so I'm seeing it for the first time as well. And man, I'll tell you what, that's really really well done and thought out, and I really appreciate you coming on the show to show this to us. Is there anything else that you wanted to say before we close out?
No, I think the only other thing that I missed mentioning is in this case, you saw that in my in my current configuration, I mentioned at the beginning that I'm using an L18, like a compact Logix.
Mhm.
Depending on which PLCs you're using, they have different capacity for how many Ethernet IP nodes you can connect to it. In my case, I have only 4 available connections because of the model that I have.
Mhm.
So the benefit of using something like this, some distributed I/O, is that I'm only consuming one Ethernet IP address
Oh,
on the
good
top,
point. Yeah.
and distributing all of my I/O to several I/O, right? So that means that I could have also, a vision system with Ethernet IP, maybe 2 servo drives, and that's about it. But I could have many I/O, including valves, with just one Ethernet IP connection.
Yeah, that's something you wouldn't be able to do if, for instance, you were just going to do if each of these modules were Ethernet IP themselves, then this
Exactly.
particular controller could not handle it. He just doesn't
Exactly.
have that many. But with one, you could get up to, what did you say, 80?
Wait, 80 modules, yeah.
80
80
modules
modules right
in
below, and
practical, as a practical limit.
exactly. And I guess the very last thing is, because we were talking about how to get one additional module in it. Let me show you. Let
Before
me
you go
show
to
you.
that, I just want to throw out a disclaimer. If you're going to use an L18 with 80 of these modules, do not buy the hardware before you do it, because while you will have enough Ethernet IP nodes and
The IO.
AP nodes, you may run out of memory.
Exactly.
Because there's not a lot of memory in these little PLCs. So build everything up offline and make sure you have enough memory, because these little guys, these L18s, L16s, they don't have a lot of memory. So I just want to throw that out there. You may get all your UDTs in there, but you may have no room to program left. So just
That's
a
an
caveat.
excellent point. That's an
Yep.
excellent point. Just last thing, because I don't want this to be an open topic. This is the application note that I was referring to. So it's CPX-AP-I with Ethernet IP, and it explains most of in detail, everything that I showed you today. But the one thing that I wanted to show you here is this section 4.3, and it basically says Ethernet IP, insert module using nested data types. So
Perfect.
if we jump there to that page 24, this is already documented in here, and it shows you step by step how to do it. But anyways, that's available online. And yeah, I really appreciate, Shawn, the opportunity coming on to your show. Great stuff, and I look forward to collaborating more often with you.
Well, thank you. I really appreciate coming on the show and doing a tech tip for us. And I hope that you folks in the audience let us know what you think. And thank you again, Sandra, for coming on. Really appreciate it.
No problem, Shawn.
Well, I hope you enjoyed that product overview and demonstration on how you can import the configuration right in the Studio 5000. I think they did a great job on that input utility, and hats off to Festo on that. Now, I also want to thank Sandro for just taking the time out of his busy schedule to put that all together. You can see he had multiple cameras and screens, and he was switching back and forth. So it took him a lot of work to put that together, and I really appreciate him coming on Automation Tech Tips to show us how to do all that. I'm sure it'll be extremely helpful to many people throughout the coming months and years. With that said, I want to thank you for watching, and I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.